I mean, you can. This is, hey man, this is the second one of these I've already bought. They're all broken. I think so, but again, I haven't read. I haven't registered as a student, so. Okay, guys. So let me get started here. I need to show you. I'm gonna put this away for one thing. We don't need this at the moment. And turn this off. All right, so I'm supposed to tell you guys how to solve absolute value equations and inequalities, right? So let's take a look at how to solve those kind of problems. Man, I've been bringing chalk here right up until today, and of course today there's hardly a piece of chalk up here. Oh man, one on the ground. Oh, that little nub. I'll get stuck if I go down there. Oh, here's some. They got some hiding in the back. Haha. Well, sort of. Little nubs. It'll work. Okay, so. So I want to talk about solving equations and inequalities. Involving I got to be careful to spell right, otherwise you guys are going to make fun of me again. Absolute value. It's okay. So the key thing about absolute value, right, is that the absolute value of A, right, is equal to plus or minus A, right? And to be more specific, it's A if A is greater than or equal to 0, and it's minus A if A happens to be negative, right? So that's the way absolute value works. So when we're solving an equation involving absolute value, we have to take care to address both of those possibilities, the plus and the minus. So let me show you an example. Suppose we're going to solve the absolute value of 3x plus 7 equals to, I don't know, 10. How do you solve this kind of equation? Do what? You say what? Say 3x plus 7 equals to what? So the way I would do it, I would say, well, that means that this is equal to plus or minus 10. Right? I mean, okay, so like logically speaking, plus or minus this has to be equal to 10, right? But this does not give me joy. So I always just go straight to saying 3x plus 7 equals to plus or minus 10, because if you think about it, that's logically equivalent to like what's right above it. So let me just erase that. Oh man. This is not an eraser. This is a smudger. It's okay. I came prepared. Ha. All right. So plus or minus 10. And then so this gives me 3x. Subtract 7 from both sides, right? Plus or minus 10 minus 7. And then what? So I divide by 3, right? So x equals to plus or minus 10 minus 7 divided by 3. And then we can break out the plus and the minus. What does that give us? So we've got 10 minus 7 over 3, or minus 10 minus 7 over 3. In other words, the solutions are, what's 10 minus 7? 3 over 3, 1. Or, what's the other solution? Negative 1, not so lucky. Yeah, negative 17 over 3. So it's kind of ugly, but there you go. One of those pesky fractions we were trying to get away from, but it looks like they're here to stay. Now, that's one way you could solve this. There's another way you could solve this. And I'll show you both ways. You can decide which way you like better, okay? So the other way to solve this, it's almost the same thing. So 3x plus 7 equals to 10. So basically, logically, there are two possibilities, right? So one, you have 3. Sorry, the one is still in the chalk. There you go. Yeah. Watch me for that. I'll do that. So 3x plus 7 equals to 10. That's case 1, right? Case 2, minus, or rather, 3x plus 7 equals to minus 10. And we can just write both of them down and solve them separately. So, I mean, you be the judge whether you want to use the plus-minus notation or if you want to solve two equations, right? Which is a better way? I mean, I don't think there's a right answer to that. It's just a question of style. You can go either way, as far as I'm concerned, as long as you show work and find two answers to this problem, right? There are two answers. Does that make sense?
So you don't have to find a positive answer and a negative answer?
There doesn't always have to be a positive and a negative answer. It could be that they're both positive. Yeah, there may or may not be fractions. Like, if you guys ever, I don't have a photographic memory of the rest of the course. I can't remember, and I keep having, I remember stuff from pre-calculus, so forgive me if this is nothing you ever do, but generically speaking, like the absolute value graph more or less looks like this. Like this is the absolute value graph. And so when you set that equal to a constant, you're going to get like two solutions possibly. And those points of intersection, they could happen both in the positive region. They could happen one positive, one negative. They could happen both negative also. So like to make them both positive, I could do something like absolute value of, x minus 6 equal to 1. I think that will give me two positive solutions. I'm pretty sure the solutions are 5 and 7. So if you guys, I'm responding to a question, are the solutions always positive and negative? Like that's why I'm chasing this rabbit, just to remind you. So watch out for that as I lecture. Usually the most confusing part of my lecture is when I'm reacting to a question somebody's asked. So if you miss the question they asked, it may be really weird what I do. But that's equal to 7 or 5, right? So this example, so this plot I'm plotting here, this is the y-axis, this is the x-axis, this point's actually 6, and we're looking at, this is the graph of y equals the absolute value of x minus 6, but we might do that kind of thing later in the course. At the moment, we're focused like a laser on solving equations, right? We're not graphing equations yet in here, right? So ignore that. unless it helps you. It helps me to anticipate like possibilities, but okay. Let's work another example here. I'm gonna add some noise to this one, so to speak. So solve absolute value of 3x. I keep doing 3, but oh well. Minus 8. Close the absolute value. Plus 6 equals to 5. All right. So what do we first thing you want to do is isolate the absolute value. So absolute value of 3x minus 8 equals to what? 5 minus 6, otherwise known as minus 1. Now you might be tempted to go, oh, okay, so then that means 3x minus 8 is equal to plus or minus minus 1 and go from there, right? But you shouldn't do that. Why? Why shouldn't you do that? The big difference here is this one we found the absolute value is equal to a negative number. One of the key properties of absolute value that we should remember as we're working with problems with absolute value is that the absolute value of A is greater than or equal to 0. Right? This is a key property of absolute value. So if I have an equation which is absolute value of stuff equals negative, game over, there's no solution. So that's it. We're done. No solution. So when I worked before, we had absolute value of stuff equal to 10, right? Can an absolute value of some quantity be 10? Sure. It's got to be positive or 0 at worst. Yeah. Mm-hmm. Right. You know, it's really the absolute value. We've built it from the square root. If you want a formula for it, like this is a formula for absolute value. It's built from the positive square root. And I mean, the same is true if we have an equation involving square root. Like if you try to solve the square root of x equals to minus 3, in the same sense, you can't find a solution because the square root is by definition non-negative. So like same animal. All right, let me try to look at another one. I don't know if you even have any homework like this, but I think it might be interesting to try to solve. So let's try to solve 2x plus 3, absolute value, plus x equals to 2. How do we solve this equation? Combine like terms. Yeah, we'd like to do that, but that absolute value is cramping our style, right? I mean, so yeah, let's, but I like your general direction, so I think we should isolate the absolute value, right? So now we have choices. We can either use the plus minus notation or we can break into cases. Break into cases? Okay, cases. Case 1. 2x plus 3 equals to 2 minus x, right? Case 2 is minus parentheses 2x plus 3 equals to 2 minus x. You notice you got a choice. You can either put the minus on the left-hand side or the right-hand side. I mean, it's up to you. It's got to go one place or the other for case 2, right? And now we're back to day 1, right? We can solve these linear equations in one variable. You know? So bring all the x's to one side, bring all the constants to the other. This gives me 3x equals to 2 minus 3, which is minus 1, right? I'm going to make another step on the other side. I'm going to distribute minus 2x minus 3 equals to 2 minus x. So this gives me minus 2x plus x equals to 2 plus 3. So I added 3 and I added x to that equation. I lost you at case 2? I showed less steps in case 1, but I lost you in case 2. So we have to distribute, yeah, go ahead. So, right.
Only reason it's minus 3 because on that one you only have minus times a positive equals a
This minus here, is it this step that's confusing? This one?
Yeah.
So what I did, here, I mean, I'll,
Why did you
here.
change the 3 to a negative?
That one?
Yeah.
Because minus 2x plus 3 is by definition like minus 1 times 2x plus 3, so then we have to distribute. I mean, we distribute the minus 1 multiplication through. So what I did here was I added 3 and I added x to both sides. And when I do that, the 3's cancel on the left-hand side and the x's cancel on the right-hand side, right? And that leaves us with minus x, collecting this and that together, equals to what? 5. Yeah, 5. So x equals to negative 5. And on the other side, we've got what? This is what you got? Yay! So these really are not that different than what we did on day 1. It's just we got to take care of the 2 cases, the plus and the minus, right? Does that make sense? Now, I actually took about 10 minutes of class just to talk about the arithmetic of fractions in the other section. Because I was talking to a friend of mine who's taught this kind of algebra many, many times. And you know, she always has like super high course evaluations, which was interesting because she would regularly fail 1/3 to 2/3 of her class. she's got pretty high standards. But the thing is, when she failed people, she do it with a smile. Like, yeah, you need to get your scores up and blah, blah, blah. And, if you come to my office and so forth and so on. And she just say it with a smile, right? And so, students understood it was whatever they hadn't done. It wasn't really on Stephanie. And so she also had super high course evaluations. But she does, she do care deeply for her students and try to do the best for them, of course, and that's the other reason. I think what's the saying? You catch more flies with honey or whatever. I don't know, but what she said was that it was well worth my effort to spend 10 minutes just talking about how to add fractions in here. Because really that skill set is a lot of what you're struggling with in other problems. And so maybe if we just spend 10 minutes on that, it'll pay off over the semester, right? So I'm going to take a slight detour from this. Then we'll come back to this. When we come back to this, we're going to instead look at inequalities, how to solve inequalities involving absolute value, all right? So we got to do that still. But first, a detour into fractions. So I'll start out with the sort of basic problem. How do you say 2/3 plus, 4/7? How would you add those fractions? Like how do we do that? Common denominator, right? So what common denominator should I try to go with here? I heard 21. So how do I make that, how do I create, right, multiply by 7/7, right? Because that's the number 1. Oops. And then, but I only do that for the first one. The second one, I multiply by a different version of 1, like that, right? And one of the things that you might notice about this is, like, how do we multiply fractions, right? That's a question that's always with us. But if we have a over b times c over d, how does that work? We do a times c, right? Over b times d. That's the way we multiply fractions, right? So that's why here we get 14 over 21 plus 12 over 21, right? And that's another thing. If we have a over b plus c over b, one of the rules of algebra is that we get a plus c over b. But we need to have a common denominator, right? So what's that give us? Oh, I wanted to make it 28, but it is not. 28 over 21? Right. 26 over 21. You guys are right.
1 and 5 over 21. Is it a proper fraction?
Oh, yeah, we don't do that. Yeah, mixed numbers. Mixed numbers are dead to us. We do not use mixed numbers. We don't believe in mixed numbers in here. You can if you want, but it's not helpful. Like, let me show you why. So as a mixed number, this would be, like you said, 1. You're right. Like, that's good. But I think I told you guys this before. I'll tell you it again. The reason I don't like this is because no one writes 1 plus 5/21, right? What do you guys write? You write this, right? Because nobody can be bothered to write the plus. No one can be bothered to write the plus. And see, then, if you mix this with all the best of intentions with ordinary rules of algebra, you multiply this by 21, you're awful tempted to say that this is equal to what? 1 times 5, right? Because the 21s cancel, don't they? So this is equal to 5, except it's not equal to 5, because the correct algebra is this. Which, when you distribute, you get 21 plus 21 times 5 over 21, which is equal to 21 plus 5, which is equal to 26. And 26 and 5, these are not the same number. One of these is wrong, and one of these is right. The one that's wrong is the mixed number, which omits the plus, which is the dominant notation used in American education today. And it is not helpful to students for this reason. It sets you guys up for the fall in algebra. It's a bad notation. We should stop using it. That's my opinion. But anyway. So that's why I'd never ask a student to write a mixed number answer. Because I think it's dangerous. It's a dangerous game. So anyway. But you guys do spend a lot of energy in your previous math classes changing your answers to mixed numbers, don't you? Yeah. I also don't care about rationalizing denominators. Like, later in this course, you might have an answer like 3 over 2 plus the square root of 7. And other courses will teach you that you have to take that and you have to multiply by 2 minus root 7 over 2 minus root 7 to bring the square root upstairs. I don't care. This is a legitimate number. This is the answer later on. Unless, of course, I say rationalize the denominator, but that's, I would do that especially. I don't know. Okay, so what else is often a sticking point with fractions? What if we have something like 5 minus 1/3? Then what do we do if we want to simplify that? Put a 1 under the 5? But that won't help because it's not the same denominator. Right. I mean, you got the right idea. We put a 1, if you think about that as a 1, right? What's the least common multiple of 1 and 3? It's 3. Right? So the denominator you're looking for here is 3. In other words, what you really want to do is just convert this 5 to thirds. How many thirds is 5? If you got pizzas with 3 slices, and you got 5 pizzas, how many slices of pizza do you got? 15, right? You're like, who are these people that are making pizzas with 3 slices? It seems like kind of ridiculous, right? But you could imagine a 3-slice pizza. I don't really recommend it. It's making me hungry. 15 over 3 minus 1/3, right? How did I get 15 over 3? I did that multiplied by 1 again, right? So that's 5 times 3 over 3, which is 15 over 3, right? And then I have a common denominator, so I can subtract. That gives me 14 over 3. By the way, that shows you another sometimes easy to forget rule. If we have a number times a fraction, how does it work? What do? We just multiply the number into the numerator, right? So I have seen students get stuck on algebra problems because they didn't understand that you can bring that multiplication outside the fraction into the numerator of the fraction. This is a freedom which we can exercise, right? Let's talk about division. Division always, causes trouble in math and society, I suppose. Let's see here. We're all too divided. Sorry, I'll shut up. 2/3 divided by 17/5. So this is probably one of the last times you'll see me draw this symbol, divides by. This is something for elementary school math. It's not something for here. It may be in your book even, but I try hard to avoid that symbol in the mathematics that I do. Why? Because I much prefer the following. Now, this is not That objection, my objection to mixed numbers is substantive. I've showed you a problem with that notation. My objection to the divides by, it's just a matter of taste. So it's like, what's your favorite color? You're wrong. It's like that, right? Like your favorite color should be green because my favorite color is green. It's not a reasonable argument, right? In the same way I'm saying don't use divides by. But I just prefer this notation, honestly, folks, like this, because it's just how I remember all my rules of algebra. Because then I can say things to you like, the denominator of the denominator is the numerator. Or yeah, so basically the rule is we keep the 2 where it is, we bring the 5 upstairs, we keep the 17 where it is, and we bring the 3 downstairs. In other words, the rule that, yeah, I mean, so if we have like A over B over C over D, the way it works.
So is it kind of the rule kind of like cross multiply, you put everything like 2 and 5 on top, and then like, you get what I'm saying?
It's like cross multiply. I mean, yeah, pragmatically speaking, if you want to think about it in terms of cross multiplication over here, I mean, that's not wrong. I mean, 2 times 5 goes there, 3 times 17 goes down here. That's just not my mnemonic. I mean, that's not how I remember how I process algebra. I think in that notation, honestly. I'm just telling you. But this is A times D divided by B times C. So like that, there you go. This is another rule of algebra. If you want to simplify, what's this called? This is called the compound fraction, right? Now, I'd rather have a compound fraction than a compound fracture, but do you guys know what a compound fracture is? What does it mean? What does it mean for a fracture to be compound? Is that what it means? I thought it means the bone is showing. Does it mean the bone? What does it mean? What do you call a fracture when the bone come out the skin? What's that? That's compound fracture? Ah, funny. I haven't played. Rupture the skin. I don't know. I know I don't want to get one. You might be right. It might be. Is it just a clean break? Is compound fracture? I don't know. I know you don't want to get a compound fracture. I know that much.
I don't want to get any kind of fracture.
No type of fracture at all? Yeah, not really. Okay, so can we? So this is what? 10 over 51, right? That's pretty much it. Oh, open fracture? Okay. Hopefully that will not be relevant to this class, except that you looked it up? Yes.
I'll tell you what was just told to me.
What was just told to you? Wait a minute.
He told me random stuff over.
I don't know.
A lawnmower. What? How do you run?
You see, you run yourself over with a lawnmower when you're 4?
How did you even get a drive?
That is a quality story.
You just whispered that to me. I was like, what?
I mean, there was a rumor at school I was when I was growing up. There's a kid without a pinky toe. His pinky toe got cut off by a lawnmower, but I never seen it.
Oh, there's a blade running on. They just ran on there.
Oh, okay. That's good.
The blades are off. My dad was showing.
I see. You know, they used to let you back up on lawnmowers, but they've got this stupid safety thing to stop you from backing up. Do you know how to disable that?
Back up.
Yeah, like you can mow in reverse. I had a lawn business when I was in like high school. Your reverse works. Like the new tractors, they've got it so if you go in reverse, the deck disengages. It's a safety feature.
I don't know.
No? Yours old? Yeah, see, mine was like mid-90s, you know, it was fine. But that's really important. I do about 30% of my mowing going in reverse, you know, tight spots and stuff, but like a lawn tractor. Yeah, it's okay. I'm hopefully be in the market for buying a lawn tractor here in a few weeks. I need to find somebody who can disable the backwards thing for me. Oh, there's one other thing. One other thing I should talk about here, which is, what if you have something like A over B inverse times C over D? How's that work? It's called death by fractions. What do you do? All you do is this just, there's different ways to look at it. One way to look at it is when you have an inverse, you just flip the fraction and multiply. So we get, so you can do like that. All right, listen, I'm going to go back to the inequalities. I hope this helps. All right, so inequalities involving absolute value, they're a little bit tricky because well, it depends on which one, actually. So let me just, there's two cases, right? So I'm just going to tell you the general setup. Let C be positive. So if we have absolute value of A less than or equal to, I'll just do less than C, right? You can trade that for minus C less than A less than C. That's how that works. But annoyingly, if we have the absolute value of A is greater than C, then that means that either A is less than minus C or A is greater than C. So this up here is really not so different. You could rewrite this upper one as A is greater than minus C and A is less than C. So the first one is like an and the second one is like an or. They're kind of, it just so happens that in interval notation, well, there's no x here, so I can explain to you why this is true. Actually, let me just take a minute to do that. Like, where are these rules coming from? So, why? So, absolute value of A less than C, right? Gives you two things, right? On the one hand, it could give you A is less than C, or what? Minus A is less than C, right? Because the absolute value is either plus or minus A. So A less than C, that one. How about the other one? How do we change that to A? Well, add A. Not wrong. Add A, so we get 0 is less than C plus A. Yeah, sure. And then do what? How about subtract C to the other side, right? Of course, the other way you could see that would be to multiply this one by minus 1. When we multiply that one by minus 1, we go to, sorry, one more. So like multiply by minus 1, we get to A greater than minus C. And then if you write this instead of greater than as a less than, it's just that. This and that, they're the same thing. They're just written, one with less than, one with greater than. Anyway, my point is just that we either have A less than C or minus C less than A, which is what I set up here, right? So that means that if we can put those together, right? Minus C is less than A is less than C. That's for less than. Yeah, sure. Once he's gone, I'll tell you what's on the final. It's obligatory. Let's see here. So, what if we go through this song and dance for the greater than? What's different about that? Why is it different? So either we have what? We have A greater than C, if the absolute value is positive, or what? Minus A greater than C, right? So A greater than C, fine. This one gives me that A is less than minus C. So can you have both of those at the same time? Can you have A is larger than C, where C is a positive quantity, and at the same time have A is less than minus C, where minus C is a negative quantity? Can A be both positive and negative at the same time? Absolutely not. So those are separate cases. So when we have absolute value is greater than, solving absolute value greater than something, we get into two cases, and they're disjoint cases. All right. So let me actually work a kind of typical homework problem for you here. I'll start with absolute value of 3x less than 6. So if I'm going to solve absolute value of 3x less than 6, I trade it for the corresponding inequality just involving 3x. I've got minus 6 less than 3x less than 6. So all right. And then how do I simplify that? How do I make it just have x? What can I do? Do what? Divide by 3, right. So minus 6 over 3, which is what? 2, yeah, so we've got 2 less than x less than 2. So there you go, that's the solution. Now what are two other ways we like to write our solution in here? Well, there's 3 other ways. What's that? As what? Add to. So the other way is called set builder notation. You could do this, x such that minus 2 less than x less than 2. So this is what's called the solution set. What I'm trying to tell you is if a student writes for me that the solution is minus 2 less than x less than 2, I know that that student understands the solution. And I can easily, from that, create the set of solutions, right? It's kind of just pedantic. What's that set in interval notation? Yeah, negative 2 to 2, right? So minus 2 to 2, interval notation. I usually ask for interval notation because it's way easier to write, right? So that's nice. And then there's one other way we can write our answer, which is what? Graphically, right? The number line. So, which isn't especially exciting in here because I've only got one color of chalk, but there you go. All right, what if instead we had absolute value of 3x greater than or equal to 6? What happens then? How do we solve that, right? There are two cases. When we're dealing with greater than, we have to break into two cases. So what are the two cases? (3x less than minus 6) or 3x greater than or equal to 6. So what I'm doing here, guys, is I'm thinking of over my general comment. My A is 3x, right? My C is equal to 6. This is what I'm thinking. Right? I mean, this is the general rule. I'm just applying it to the context that our A is 3x and the constant we're dealing with is 6. And by the way, when equality, you can throw in the equals case to both of these, right? Like, these are still true. If I put an equals here, it just slaps an equals there and an equals there. If I put an equals here, it slaps equals here and here. All right? So then what? We've got x less than or equal to minus 2, or x greater than or equal to 2. Let me do the number line first this time. So we've got less than minus 2 or greater than 2. Right? That's like this x. That's like that x. It's not the same x, right? These are distinct cases, actually. They're not overlapping. How would I write this with interval notation? So interval notation, I do minus infinity to minus 2 included, union 2 to infinity. So this right here, guys, is called the union. Have I talked about that in here yet? I can't remember. No. Let's talk about union and intersection for just a second. So, little set theory. So if I have A equals to, let's say, 1, 2, 3, and I have, say, B is equal to 1 and a cat. I mean, you can put whatever you want in the set. You can be totally abstract about it, you know. I don't know. You could put the NBA in there if you wanted. I don't know, whatever. Pick your second object. Then I can talk about A union B. What that's going to be is x such that x is in A or x is in B. Actually, let me not write this because, let me not write that, I'm sorry. Let me just do it for you. A union B is what? A union B, you just take and collect the elements together and list one of each. So like A union B, it's 1, 2, 3, and also the cat. That's union. Intersection, in contrast, we don't use intersection here as much, maybe hardly at all, but intersection is when you look at two sets and you take all the elements which are common to both. So what's the common element to A and B in my example? Just the number 1, right? So the intersection here is just the set containing just 1. So this union, what it does is it creates a new set which has everything in here and also everything in there together in one big set, which is our answer. We can also draw pictures. These are called Venn diagrams. So if this is A and this is B, if this is A and this is B, the union, it just looks like everything in both. The intersection is just the part that's common to both the set A and the set B. So you can picture them like that if you like. All right. Any questions? So I can push back the due date for the first homework since there's a lot of people here who don't have the thing done yet. But the thing is, the other homework is still due, and like it needs you need to get caught up before test one because I'm not going to push test one back. So, you know, wait a minute, is it really time for the end of class? And then some, or I'm not. You guys are trying to get me to end early, aren't you? Got 3 minutes. That's enough time for something, right? No? Talk about what? Talk about the... Okay, so it's currently due Saturday at 10. When would you like it to be due? Monday at 10 a.m.?
Or we can just, no. Before class, before we come back to class. Tuesday. Before we get to class Tuesday.
Before you get to class Tuesday. Okay, I can do that. Yeah. If I don't do that, email me. That means I forgot.